Section 9.4, we're going to learn another method for solving quadratic equation, and that method is going to be to solve by factoring. So our biggest question at the end of the hour is going to be, how do I solve a quadratic equation? And let's repeat what those look like. A quadratic equation can be written as ax squared plus bx plus c equals 0. And we're going to answer the question, how do I solve a quadratic equation, by using what we call the factoring method. So before I discuss that, what I want to do first is take a blank sheet of paper here and kind of review what we did in the last section, because we solved in 9.3. We solved equations that looked like, let's say, 2x squared minus 50 equals 0. And we solved this by isolating the x squared and then taking a square root. But keep in mind, the only reason we're able to get that x squared by itself is because there is no other x term in the quadratic. Really what that means is b is 0. There's no like 2x squared plus 4x minus 50. And so what that allows us to do is just attack that x squared by doing our inverse operations, which is what we did yesterday. We'd say add 50 to both sides, and we'd get 2x squared is equal to 50. Next, we'd eliminate this 2 by dividing by 2, and we'd get x squared is equal to 25. And lastly, we would take the square root, remembering to do the plus or minus, and we would get plus or minus 5. And prior to doing that, we had also said you could, even though we don't choose to, solve it by graphing. And had you solved that by graphing, you could go to a graphing calculator, or you could do it by hand, and this is a perfect example of why we don't solve it by graphing. You'll notice that because the b term is 0, our vertex is sitting at 0, negative 50. So it's way down at 0, negative 50. But had I graphed it on my graphing calculator, I would have found that it hits the x-axis right here and right here. And we discussed how those are called the solutions. They're what cause the y to be 0. So if you think of this as y equals, and if you think of where it's 0, we call these the x-intercepts, and they correspond to the solutions to the equation. But again, the reason we're able to do it that way is because there's no b term. Today we're going to introduce a b term into it, and we're going to have to use a method called factoring. And before I do that, I have to discuss an important property in mathematics. It's called the zero product property. And what it says is very intuitive. It says, if I were to ask you to keep track of this in your head, if I were to say put 2 in your head, multiply it by 3, then double it again, then multiply it by 4, then by 6, then by 99, then by negative 100, then by pi, then by 0, then by 10. The minute I got about here, we started losing track, and I started going faster. But the minute I said times 0, you knew the answer. Because the minute you throw 0 into a multiplication problem, the whole answer, regardless of what everything else is, becomes 0. And what that allows us to do is it allows us to solve. Watch what I mean by that. If I've got a product, 2 things, 2 factors that multiply to equal to 0, what I know is that one of them or the other one has to be equal to 0. There's no way I can multiply numbers and get a 0 out unless one of them is 0. So it allows us to figure out what x is, because I just have to figure out what makes this 0. And you can think of subtracting 2 from both sides, or for that one you can use common sense, that a negative 2 plus 2 is 0. So if I put in a negative 2 for x right here and add 2 to it, I get a 0. And it doesn't matter what happens after that. If I'm multiplying and one thing is 0, the answer is 0. on this side, when I've got 2x minus 5 is equal to 0, I just figure out what makes it equal to 0. I do the opposite, which is to add 5. And then the opposite of multiplying by 2 would be to divide by 2. So I'm going to get x is equal to 5 halves. And what that tells you in this original is that when I put in a 5 halves for x, this is some number. It's actually 2.5 plus 2, it's 4.5. But when I put 5 halves in on this side, I end up getting 5 minus 5, which is 0. So again, it doesn't matter what the other part is. If one or the other of the factors equals 0, the answer is 0. So let's go discuss this. If it's already in factored form, it's really easy. You just take and set all of the factors equal to 0. In this case, there's 2 of them, and you solve. Undo addition with subtraction. Undo multiplication with division. And I'm led to one solution. And sometimes they'll put these in what's called a roster format where they list them like in a set. But one of the solutions is -1/4. The other solution was a little bit more obvious, and I don't really need to show the word for it. But the other solution is 2. I don't like this roster format that your book uses because I think sometimes kids confuse it with a point, and this isn't a point. These are 2 answers. So I prefer it if you just say -4 and 2. Those are the solutions. Or you can, 1/4, sorry. Or you can circle them. So how about this one? What would make that equal to 0? I should have had that on there. Well, again, we've got this being multiplied by this. So either the first part has to equal 0, first factor, or the second factor has to equal 0. And I solve those. I divide by 4, or even better, I use common sense. 4 times what gives you 0, a 0. Over here, I'd subtract 1, and I get 5x is equal to -1. I divide by 5, and get x is equal to -1/5. And I have 2 solutions. So we'll do a couple of these down here, probably not all of them. But again, these are already split into their factors for you, so you really just need to consider what makes each piece 0. When there's nothing in front of the x, or when there's technically a 1 in front of it, they're easy because it's just the opposite. -1 plus 1 is 0, so -1 is a solution. 5 minus 5 is 0, so 5 is a solution. So I have 2 solutions, and you can check them. Again, you don't have to, but if I put a 5 in for x, I get 5 plus 1 is 6 times 0. And so, again, you look at what makes each piece equal to 0. Let's go look at letter D. On letter D, I've got 2 of them. Again, and I need to consider them each separately. What makes 7n minus 2 equal to 0? What makes 5n minus 4 equal 0? To undo subtraction, I add. Getting 7n is equal to 2. So undo multiplication, I divide. Getting n is equal to 2/7. That is one solution. Equivalently, over on the right-hand side, I'd add 4. To undo the subtraction, I'd get 5n is equal to 4. To undo the multiplication, I would divide, leaving me with n is equal to 4/5. So I have, again, 2 solutions. Had I graphed it, the parabola would have hit the x-axis twice at 2 ugly spots that I probably wouldn't have guessed by graphing. I would have thought this one was hitting at about 1. So again, you can see that graphing isn't the related function is not a really good method for solving. And this method's nice, but keep in mind it's kind of nice and easy on this page simply because these are already factored. I don't think we need to do that one. But let's go look at letter C. Common sense for the second factor. What plus 14 gives you 0? Well, -14. I really don't need to show work for that. On the other side, I have 2y plus 1 is equal to 0. And again, I do the opposite. So I subtract 1, and then I divide by 2, and I get y is equal to negative 1/2. So I've got two solutions to this equation. Now, although we're working with quadratics in this section pretty much exclusively, this zero product property can be applied to an infinite amount of factors. And if they multiply to equal 0, what that means is one of them has to be 0. So, although if I graph this, it will not make a parabola, because if I multiply this all out, I'd actually have an x and an x and an x and an x, and I'm going to have an x to the 5th. That's not a quadratic. It's actually called a quintic. And obviously then, for our quadratics, we usually get the two solutions because it hits the x-axis usually twice, sometimes once, sometimes not at all. Well, what that means for one like this is I'm going to get 5 solutions, which means if I were to graph this, and it actually does make a curve, what it would do is hit the x-axis 5 times. Where would that be? Well, wherever I get a 0 out. Where's that? It's where x is equal to 0, or 9x minus 8 equals 0, or x plus 3 equals 0, or x minus 4 equals 0, or, I'm going to have to go over here, 3x plus 7 equals 0. Solve the easiest ones first. X minus 4 equals 0 when x is 4. X plus 3 equals 0 when x is negative 3. X equals 0 and x equals 0. These other two, just do the opposite. Add 8, get 9x equals 8. Undo your multiplication with division. Get x equals 8/9. And undo your addition with subtraction. Undo your multiplication with division. And what I've got here is what I would call 5 solutions. 1, 2, 3, 4, 5. Had I graphed y equals all that on my graphing calculator, what you're going to see is something that dings around, but what it does is it hits the axis 1, 2, 3, 4, 5 times at these 5 spots. So, leading us on to the next page, let's begin here. What do we do and how do we use this when it actually looks like ax squared plus bx plus c? And that's what I'll do on the next video.